Hi guys, welcome back. We just talked about the stomach anatomy, and now we're gonna start talking a little bit deeper about some of the glands. In fact, the amazing mucosal and the more important gastric mucosal barrier, the GMB. Here we go. So mucosal we talked about, aka again surface mucosal cells. Full is another old aka foveolar cells. Foveolar cells. Again, not mucus cells. Mucose cells secrete mucus, made up of make up the surface epithelium of the luminal surface of the stomach. Again, they are histologically classified as simple columnar cells because they are taller than wider. They are stuck together at the sides very strongly by desmosomes in tight junctions, some gap junctions in there as well. So what? They're very stingy. They don't let things pass between the cells very good at all, especially not hydrochloric acid or pepsin. So because you don't want to, you replace these things, as we'll find, every 3-4 days, if I remember right. They're very quickly replaced. So if they get burned up by the acid, no big deal. But if the acid gets down into the deeper layers, like the lamina propria, even into the submucosal layer, it can take weeks for repair. So they don't let acid back leak. Keyword back leak means acid is spit out of the gastric glands, gastric pits, or I'm sorry, oxyntic glands, and it can come back, and if it gets through the mucosal layer, that's called back leaking. That's a bad thing. That causes ulcers. So we'll see. Made of 95% water, phospholipid, glycoproteins, and mucin. I'm not sure why I have that so big. All mucus cells secrete, this is why. All mucus cells secrete two important substances which help protect the epithelium from back leak and from damage of acid. So that those two important substances are mucus and bicarbonate anion. You remember from your biochemistry days, bicarbonate is HCO3. It's an anion, it's negatively charged in mucus, so very important. That's where the bicarbonate comes. Then that's going to protect the stomach, as we'll see here in a minute. The mucus. Now let's talk about the mucus. It comes from these little granules inside the mucosal cells called mucogen granules. They're located at the top or the apical portion of the cell. When the cell is stimulated, it secretes mucinogen via exocytosis, which is converted, we won't get into that mechanism, but it's converted to mucin, which is the back sticky tough stuff of mucus. It also contains glycoproteins, carbohydrates, which give it a cloudy appearance. So it's not only tough and sticky, but you can see it. It's cloudy and sticky looking. Because of this cloudiness, this mucus that is secreted by these epithelial cells, it's called viscous mucus or cloudy mucus or visible mucus, all these AKAs for it. Unlike mucus that is generated by mucous neck cells, the neck cells, which are actually in the glands, secrete mucus as well. The mucus that comes out of the neck cells is wimpy. It's not very thick, and the mucus that comes out of these mucous cells is very tenaciously thick almost. It has a very high pH. Does that mean it's acidic or basic? I'll assume you know that from your biochemistry. High acid means it's basic. Low acid means it's acidic, or low pH. I'm sorry, high pH means it's basic. Low pH means it's acidic. So it's the difference between those two. Now, this should have a star. Gastric mucosal barrier. You can put a star. It's kind of neat. I can kind of star as we go along here. Gastric mucosal barrier It's super, super important. That's what protects your stomach from ulcers and from gastritis. It's thick, so thick that it stops the surface mucosal cells, or it sticks to the top of the surface mucosal cells. It doesn't clog up the pits, so the gastric pits are still, it just hugs the top of the epithelium and dips down with the gastric pits. This is about 1 millimeter thick. This GMB, this gastromucosal barrier. And it forms, here we go, protective barrier against highly acidic gastric contexts, as well as pepsin. I talk about gastric acid, HCl, acid, it's all the same. You can might as well include, every time I say that, you can include pepsin in there. Pepsin can destroy protein tissue as well. It can rip up the walls if it gets through that gastric mucosal barrier. So it's just as evil. Authors call the GMB all sorts of things: gastric mucosal barrier, gastroduodenal mucosal, bicarbonate barrier. There's all sorts of things. Okay, talk about bicarbonate ion a little bit. HCO3, bicarbonate. I use those terms interchangeably. It's also, in addition to mucus, the mucose cells secrete bicarbonate ion. So bicarbonate's important as well. It makes the mucus, this mucosal barrier, even thicker. So it's good stuff. It's a little basic as well, so it can kind of mitigate the pH of the acid as well. We'll see a little drawing. Oh, actually, we're going to see it right now. Secretion of this anion. Who am I talking about? Who's the anion? HCO3. This bicarbonate. Secretion of this bicarbonate is a very important component, and we'll see when that breaks down, things go bad. So this is not biochemistry, but you should have had something like this in biochemistry and know a little bit. So there's the bicarbonate being secreted. We'll talk about the alkaline tide a little bit, but it can bind with the acid to form water and CO2. Maybe that's why some people burp, is because of this reaction, CO2. Some of it can get into the lumen. Okay, there's another pretty cool picture. I put this in here just to show you what the gastric mucosal barrier looks like. This is the gastric mucosal barrier. Notice it does not bridge the gastric pit, which is right here. Here's the gastric pit. It follows and kind of peters out as it gets down inside here. The drawing should have stopped it about here. It stopped it a little bit low. You don't see it down here. Okay, so that's the gastric mucosal barrier. Say other so we already said this. Mucosal neck cells, they are also secrete a mucus. It's not as thick. In fact, it can even be acidic a little bit, some research says, but it's not as basic, it's not as thick as the mucosal cells mucus. It's more watery, thin, it's more soluble. Okay, it still contributes, helps the gastric mucosal barrier, but not nearly as much. Now, authors aren't unanimous on this, but some authors have said that this thinner mucus wraps itself around food and makes it slippery, so it has a little bit, can pass and be ground up a little bit. So it coats foods, according to some authors. Now, this is an important one here too. Let's put a star here. It says PGE2. Prostaglandin E2, or just PGE2, very important signaling molecule, also secreted from the mucosal cells, from the mucose cells. So now we have mucus being secreted, and now we have PGE, PGE, like our electric company, PGE2 also being secreted as well. In fact, almost all the cells secrete PGE2 into the bloodstream. Some authors call this a local hormone because it is secreted into the bloodstream. It doesn't go into the mucus. It doesn't go into the secreted out the basolateral portion, secreted out the bottom of the cell. So it doesn't get into the lumen. It doesn't get into the mucosal gastric barrier. So, here it is right here. It's released into the interstitium. Where's the interstitium? That is below where the cell is. remember, cells are tightly junctioned together. There's no interstitium between them. There's no room. So the interstitium is below. Okay. So PG and E, what are its actions? I guess I'm not going to be starring all this stuff. That's going to take too long. But it takes quarters to develop those stars. But it's so PG. This is a great question, great physiology question, and my question too, because these are kind of hormone functions. So PGE2 is autocrine and paracrine action. It stimulates. Autocrine means it stimulates itself. It's released from the cell, and it has receptors on the top of the cell, and it stimulates itself. It also stimulates neighboring cells, neighboring mucosal cells. And what does it stimulate it to do? Who cares about this dumb PG&E? Because it stimulates cells to release our friend bicarbonate. So it stimulates the release of bicarbonate, which beefs up the gastric mucosal barrier. So indirectly speaking, PG&E2 is very important for that super important gastric mucosal barrier. Okay, makes sense? It also does another thing here. It indirectly stimulates the release of hydrochloric acid from the parietal cells. Okay, it does this by inhibiting the release of histamine from the ECL cells. So we'll talk about this more. We'll have our own slides on this. We're not going to get to this today. We've got to be getting close to done, right? I lost track of how many slides we've done, but I know we kind of got behind this week. We lost 5 hours this week, right? We lost everything this week, so better keep moving here. Okay, we'll talk about that mechanism later. So PG&E cells, very important. Here's a little slide in autocrine. Here's a cell where it creates a signaling molecule and it spits it out, and it has receptors on neighboring cells, which would be a paracrine function, but it also has cells on itself, so it stimulates itself to keep this cycle going. That's autocrine action. Paracrine means, so it's stimulating, here's the signaling molecule being secreted, and this one binds to receptors on another cell. So this is just an example of a paracrine signaling. If it had receptors on itself, it would be autocrine as well, but it doesn't. Okay, let's see. So therefore, PGE2 strengthens the gastric mucosal barrier by increasing its pH. How does it increase its pH? Because it spits out bicarbonate anion, which is a little bit, you can think of it as basic. I mean, it's really a buffer, but we're not going to get that crazy into this. And it thickens it up. So very important role in the protection of mucosal layer from gastric acid, from pepsin, and their sequelae. Add that to your list. I think I told you already. Sequelae is a vocabulary list word. That means the stuff that happens as a result of. The sequelae of acid destroying the mucosa is an inflammation of the stomach wall, which is gastritis, or a deeper gastritis is erosion, and a deeper erosion is an ulcer. We'll talk about those specifically. Okay. Let's get through NSAIDs. I think I'm going to call it a day. We'll see. I still have to upload all this stuff. So, NSAIDs, PG2, should be review, I think. PG2 or prostaglandin E2. So in order for the signaling molecule PG2 to be released, there's an enzyme, a very important enzyme. So remember, where's PGE2 released from? Those mucosal cells that line the gut of the stomach, or the intestinal part of the stomach. So in order for them to work, to be released and do their job, right, there's an enzyme involved. And that enzyme is cyclooxygenase, or the infamous COX enzyme. Specifically, in the stomach, it's usually COX-1 that is involved in this reaction. In fact, we used to think it was only COX-1. But then the COX-2, after COX-2 inhibitors came into the world, were born, we found that if you block COX-1 in the stomach with if you block COX-1 with NSAIDs, COX-2 starts doing the same job. So COX-2 kind of like converts into, well, it doesn't convert into COX-1, but it can pick up the job duties if COX-1 gets blocked. All right, so cyclooxygenase is also moved in and out, or involved in out of control unwanted inflammation processes. So you can see the sprained ankle guy right here, all purple. You treat many of these in your day. The inflammation process can get out of control. Cyclooxygenase works too hard and it causes an inflammation. So you take NSAIDs to stop this thing, and in addition to doing therapy, you can do like a lymph massage and ice, low volt muscle stimulation, all sorts of stuff. But these NSAIDs attack COX-1, and so it'll help stop the inflammation. So great, everything, patient's getting better. But what's not so great, it also knocks out the cyclooxygenase in the gastric mucosa. The COX-1 gets knocked out of action. So what? Who cares about that? Well, what does it do? That's going to interfere with the production of PGE2. We said we need cyclooxygenase to make PGE2. So without PGE2 around, what's going to happen to acid secretion? Well, it's going to go up, right? Therefore, it weakens the gastric, or I don't think we talked about that, but it's going to weaken the gastric mucosal barrier, and it's going to stimulate the release of acids as well. Part of the ECL cells I don't think we talked about, but bottom line is if you knock out cyclooxygenase in the stomach, you're also knocking out the gastric mucosal barrier. And that is what's protecting our stomach from inflammation and pain. Okay, this is why long-term use of NSAIDs can lead to gastritis, ulceration, even perforation. It hinders the production, the PGE2 production. If you hinder PGE2 production, you increase the production of acid because histamine can no longer bind or no longer block the release of histamine from the ECL cells. We're going to talk about this specifically. And it decreases bicarbonate. We'd already talked about that. It decreases bicarbonate ion. So therefore, without bicarbonate ion, if that decreases, that the gastric mucosal barrier will be thinner. It'll be more acidy. It'll be less protective. Okay, so it opens up the stomach to damage and pain and ulcers and all sorts of stuff. Okay, look at that for a minute. A little water break. That is pain. That's an ulcer. That's a gastric ulcer in the body of the stomach. Patient, low back pain patient, had taken NSAIDs a long time and his stomach went out. Did an endoscopic eval, and there you go. Other things that can protect the gastric mucosa from HCl. Fresh young stud mucosal cells. So because the stem cells in that isthmic region, there's stem cells in that isthmic region, and they can produce mucosal cells very quickly, between 3 to 7 days. That's a heck of a turnover. Dermatology, we'll talk about the skin, has about a 30-day turnover, 20 to 30 day. So it's really cranking these out. So you always have fresh, young, strong epithelial or mucosal cells. So that mechanism in and of itself helps protect the submucosa and the lamina propria and the layers beneath from damage because of that quick turnover. Okay, everything I said right there. Let's see. Another protective mechanism is the lamina propria itself. It has blood vessels. It has capillaries in it. So the lamina propria follows the contour of the gastric pits. If you do get some back leak and it penetrates the mucosal layer and it gets in and it gets deep, the blood vessels, the lamina propria, can actually swallow up those hydrogen ions. As the H cell breaks down into chloride and hydrogen, it can swallow those and take it away. So that's great. So that protects the deeper tissue from permanent injury. And that mechanism, that kind of vacuum cleaner like mechanism, works fine as long as there's not too much hydrogen ion. If it gets overwhelmed with hydrogen ion, and that's just acid, right? Hydrogen ion is acid. Then you'll go right through it and get into the submucosal layer. Okay, back leak of hydrogen. We talked about this a lot already. In order for proper digestion, it's important to keep acid in the stomach and don't let it back leak into the mucosa. And again, back leak is prevented by the GMB, gastric mucosal barrier, as well as the tight junctions. I can see a question like what prevents back leak? Gastric mucosal barrier, tight junctions, that vacuum cleaner action of the vessels in the lamina propria. If back leak does not occur, if back leak does occur, not only does it cause ulcers, but it can interfere with protein digestion. How can it interfere with protein digestion? Well, you need those H ions, you need that hydrochloric acid and those hydrogen ions floating in the lumina of the stomach to break down the proteins. If you got them leaking through the mucosa into the submucosa, you can't break down proteins anymore. Well, you probably won't be eating anything because your stomach will be so upset. The sequelae of back leak. The gastric mucosal barrier can be damaged by toxic substances such as aspirin and alcohol. So what? Such damage will allow back leak to occur. It knocks out the gastric mucosal barrier and makes it susceptible to back leak. So that causes gastritis. If it keeps going on, erosion. If it keeps going on, ulceration. If it keeps going on, we could add perforation in there, but I'm much too tired at this point. Let's see. Lamina propria. Are we starting new? I think we're almost done here. Lamina propria, don't need to say too much. Again, that is the surface the mucosal cells sit on. It surrounds and protects the gastric pits. It's got blood vessels, so it helps soak up any back leak hydrogen ions. Filled with blood vessels, said this already. Brings nutrients. It feeds. This is where it feeds the mucosal cells. Can carry hydrogen away and back leak hydrogen ion away, as we said. Therefore, it helps with the protection mechanism as long as it's not overloaded. Everything we kind of said already. It also contains lymph tissue, small lymph nodules to fight bugs that might get into there. It also contains some very important stuff for cells for acid production called the enterochromaffin-like cells, ECL cells. ECL cells don't sit at the luminal barrier of the gastric glands or of the oxyntic glands or the gastric pit. They set a little bit deeper, so we'll talk about those in a little bit. Okay, muscular mucosae. So this is the third layer of the mucosa, and it's the outermost portion away from the lumen. It's made of smooth muscle. It can contract and rearrange and contour. It can shape the rugae a little bit. Other than that, it's really not very exciting. That is definitely here. I think we're going to stop it right here. I don't know if I'm going to keep going. I think we've probably done enough slides. All right.